All right, in this lesson, we're gonna solve exponential equations. All right, this set of notes has both exponential and logarithmic, but I'm gonna do this video in two parts. I'm gonna do the first part with exponential equations. Okay, so to solve exponential equations, some of these we have done before, right? We've done the pretty simple cases where we're able to change one side to have the base of the other, right? So let's take something super simple like 2 to the power of x equals 8, right? You guys know that we can change this 8 to have a base of 2, right? This is 2 to the third, and then you can cross, and then you get x equals 3. All right, this is one example of an exponential equation, right? This is the nicest case that you might encounter, right? But let's just say I have 2 to the power of x equals 10, right? Well, there's no way to rewrite 10 to have a base of 2, right? I can't write 10 as 2 to the power of something, right? I know 2 to the power of 3 is 8, and I know 2 to the power of 4 is 16, so I know that whatever this number is has to be between 3 and 4, all right? But I don't know the exact number, all right? To do that, what we do is we take a log on both sides of our equation, right? Either a log with the same base as whatever has the exponent, or just a regular log or ln, right? I typically will do that. I will typically do just log or ln just because these types of problems will have you plug into the calculator anyways, right? We'll never have you leave these answers exact, right? We always want for these a decimal approximation. All right, so let's just do a couple simple equations. Let's look at numbers 1 and 2, right? Number 1, I have e to the power of negative x squared equals e to the negative 3x minus 4. This one's actually pretty simple, right? We already see that e is the base on both sides, so all you have to do is cross them out. And then you're left with negative x squared equals negative 3x minus 4, and then this just becomes a quadratic equation, right? We can add x squared on both sides, and then we end up with x squared minus 3x minus 4 equals 0. And then you just factor and solve like normal, right? We get x minus 4, x plus 1 equals 0. And then you get x equals 4 and x equals negative 1. All right? So we get two answers here. We don't have to check them, all right? You're going to see that when we get to the logs, right? So the second part of this lesson, you actually do have to check your answers, but these you don't have to check them. All right, because the domain of exponents, right, you guys probably remember from your test and quiz, right, the domain of exponential functions are all real numbers, right? So you can have any value for x. All right, let's do the exact same thing over here. All right, I see an e and an e, so we can simply cross them out and then solve whatever equation's left over, right? This is just 101 property. You guys have done this probably 100 times at this point. All right, so we get 2x equals x squared minus 8. Let's subtract 2x on both sides, and so we get x squared minus 2x minus 8 equals 0. And then this is also factorable, so we get x minus 4, x plus 2 equals 0. And so we get x equals 4 and x equals negative 2. All right, so we get two answers again. Again, the domain of exponential functions are all real numbers, so I don't have to check those answers. I know that they are correct. All right. Now, when you look at something like number 3, this is one that your instincts are probably telling you to rewrite 42 to have a base of 2. But think about it, right? I know that 2 to the power of 5 is 32, right? That's not quite 42, and 2 to the power of 6 is 64, right? So between 5 and 6, I mean, really, I don't know what number that is that I'm going to change 2 to be the base of this, right? I don't really know how to do that. So what we do in these types of problems, this is my approach to it, right? If you want to check out how Mrs. Meadows does it, right, she typically will do a log with a base of 2, or whatever has the exponent, that's what she'll do, and then she'll do change of base. I like to do the same thing for every single problem. So I'm just going to strictly do a log or an ln, right? So I'm going to do, for this one, ln, right? Let's just do ln on both sides. All right, why did I ln both sides? Well, one, what you do to one side, you have to do to the other. But the point of doing an ln is that since logs and exponents are inverses of each other, the log that we just put is going to get rid of our exponent, right? How does that work? Well, if we know that there's an exponent here, one of our properties of exponents that we learned in the previous lesson is we can move this out front, and then it becomes x times ln of 2 equals ln of 42, right? Just by taking a log on both sides, you got rid of the exponent, right? You moved the x to the front, and now you're free to do whatever you want with it, right? So what I'm going to do now to get the x completely by itself is I'm going to divide both sides by ln of 2. All right, and then we get x equals ln of 42 over ln of 2, right? And then that's our exact answer, right? But again, maybe you took a slightly different approach to it, right? I know that Ms. Meadows, what she does is she does log base 2 on both sides, and then the exact answer would be log base 2 of 42. All right, but so just to account for little computational discrepancies that like maybe some of you get a different exact answer that's also equally valid, let's plug it into the calculator and let's see what we get. And when we do this, we should get x is approximately, I'm just going to do 3 decimal places, right? I'm going to do 5.392. And then this is our answer to a couple of decimal places. All right, so hopefully shouldn't be too bad. I know I did a lot of talking, but the next one should go a little bit faster. All right. Notice here, the only difference between this one and the one that we just did is that now there is a 2 in front. All right, this 2 does not have an exponent, so you are free to do whatever you want with this 2, right? So I want to make sure that this 5 to the power of x is by itself. I want whatever has an exponent by itself. So what we're going to do, let's divide both sides by 2. So then we get 5 to the power of x equals 16. Once again, right, we can't really get 16 to have a base of 5. So what we're going to do is we're going to log both sides, right? And just to show you that it works with anything, whether it's ln or log base, whatever, right? I'm going to do just log, right? You guys have a log button in your calculator, so I'm going to do log of this one, right? It doesn't really matter what you do as long as you do the same exact thing to both sides. All right, and then the point of doing that is we can use one of our properties of exponents, our power property, and I can bring that x out front. This is x log of 5 equals log of 16. All right, and then you can divide both sides by log of 5. Right, log of 5 is just a number, right? You plug it in the calculator, you get some decimal numbers, so you can divide with it, you can do whatever you want with it, right? Divide both sides by log of 5, and then you get x equals log of 16 over log of 5. All right, this is our exact answer, right? It's almost as simple as it gets. So let's put this into the calculator and then let's get a decimal approximation. All right, so if you do log 16 over log of 5, you should get 1.723. All right, so 3 decimal places. All right, hopefully not too bad. All right, let me zoom out. All right, so let's try the same thing over here. We have e to the power of x plus 5 equals 60. All right, once again, I want to try to get whatever has the exponent by itself. So to do that, I'm going to subtract 5 on both sides. And then you get e to the x equals 55. All right. And then once again, you're going to either log or ln both sides to get rid of that exponent. I'm going to do ln for this one, right? Just because, all right, hopefully some of you can see it already. Ln and e are going to cancel out, right? You can still move that x to the front, but then you're left with x times ln of e, and we already know from previous lessons that ln and e cancel out. So we're just left with x equals ln of 55. All right, that's our exact answer. All right, should be pretty simple. Now let's plug this into the calculator and then let's get an answer, right? Just type in very simply ln of 55, and then you should get 4.007 to 3 decimal places. All right, hopefully not too bad, right? You could have done log for this one as well, right? Like you could have logged both sides, but ln was much simpler because it immediately canceled out the e. And then hopefully you notice the next one's exactly the same. All right, so let's add 7 on both sides. Let's get the e completely by itself. So then we get e to the x equals 30. And then once again, I'm going to ln both sides. And one of our properties of logs is that ln and e have the same base, so they cancel out. We get x equals ln of 30. All right, and then that's our exact answer. Let's plug this into the calculator, and let's get a decimal approximation. We should get 3.401. All right, shouldn't be too bad. Okay, now let's try this one. All right, some of these get a little bit more complicated, but hopefully not by too much, right? This just requires a little bit more steps than some of the others, but still the idea is the same. You want to get whatever has the exponent, in this case the 3, completely by itself. All right, so isolate it, right? Let's add 4 on both sides. And then so we get 2 times 3 to the 2x minus 5 equals 4. And then we have a lingering 2 out front that doesn't have an exponent, so I can divide both sides by 2. That cancels out, and then we get 3 to the 2x minus 5 equals 2. And then just like before, to make this a little bit simpler, you can log or ln both sides, right? I'm going to stick to the same thing every time, and I'm going to ln. All right, let's ln both sides. And then when we do that, we can move this entire exponent out front. I would put it in parentheses just so that you're aware that this whole thing operates as one single unit, right? It's not like now they're free to move wherever, because we're still multiplying this whole thing by ln of 3. So it's ln of 3 equals ln of 2. All right. We got a couple more steps here, right? I want to isolate now the x, right? I want to get that by itself. So to do that, I'm going to first divide by this ln of 3. So let's divide by ln of 3. Doing that, we get 2x minus 5 equals ln of 2 over ln of 3. And then now a couple more steps. I just want to add 5 on both sides. And so I get 2x equals ln of 2 over ln of 3 plus 5. And then you can divide both sides by 2. So that cancels out, and then we get x is ln of 2 over ln of 3 plus 5 all over 2, right? Ugly answer, I know. But it is just like a normal algebra problem, right? You get ugly numbers. If you want from the beginning, you can plug it into your calculator and then get a decimal answer and then just simplify it along the way, like get a decimal answer for this and then add the 5 and then divide everything by 2. No matter what steps you choose to take, we should approach the same decimal answer. All right, so give me a second while I plug this into the calculator. And then notice that we should get an answer of 2.815. All right. So then that would be your answer for this one. All right. Let's just say you're not too positive, right? I know that this one was a challenging one. Let's just say you're not super positive that you got the right answer. You can always check, right? If you want to check your work, this isn't an absolute requirement, but maybe you're not sure that you got the right answer. Maybe you think that you made a calculator mistake. Plug in your answer, and you should get approximately a true statement, right? So I'm going to plug in 2.815. So I'm going to get 2 to the power of 3 times 2 times 2.815 minus 5 minus 4 equals 0, right? So let's just see if this is a true statement, right? When you plug in 2 times 2.815 into the calculator and then subtract 5, you should get approximately 2 times 3 to the 0.63 minus 4. And then when you do 3 to the power of 0.63 and then multiply it by 2, you should get 3.996 minus 4, which is really close to 0, right? So that's one way that you want to check, right? I'm just showing you guys just in case. I know a lot of you guys probably won't check your answer anyway. But just in case you want to be extra certain that you got it right, you could check your answer like that. All right. Let's try one more similar to this one. All right. So once again, I want whatever has the exponent completely by itself. And in that case, it's 2 to the power of x plus 5. All right. So let's isolate it. Let's subtract the 4. We get 6 to the 2 to the x plus 5 equals 18. Divide both sides by 6. And then we get 2 to the x plus 5 equals 3. All right, now that the exponent, or the base with the exponent is by itself, let's ln both sides. And then when we do that, this entire exponent is going to move out front by property of log, right? So we get x plus 5 times ln of 2 equals ln of 3. And then let's divide both sides by ln of 2. All right, and then those cancel out, and then so we get x plus 5 equals ln of 3 over ln of 2, and then you can subtract 5 on both sides. And then so you get x equals ln of 3 over ln of 2 minus 5. All right, and then that's our exact answer, right? But again, just so that everyone's on the same page, we should plug this into the calculator and then get a decimal approximation, right? And then when you plug this into the calculator, you should get x is approximately negative 3.415. All right, so yeah, those are about as tricky as they get, but I'm going to stop this lesson here for now, right? So that's, again, about as tricky as the exponential equations get, right? So if you're able to follow that along, great, right? You got most of the lesson. The next part of this lesson is going to be solving logarithmic equations, all right? But again, as promised, I'll do that in 2 parts, all right? So I'll stop it here for now.